Here's a linear graph type of question. If you hire a city bike, which is a flat fee of $8 plus $1.20 per kilometre travel, the cost is C dollars and the distance is D kilometres. Part A, show the formula for cost and D with respect to D. And part B, show a graph of C versus D. C, find the cost to travel 14 kilometres. That could be done by the math or looking at the graph. And D, find the distance to keep under $30. Again, formula is accurate and the graph will give you an approximate look. So let's have a look at, let's go black. Let's scroll down. How big can I make my page? Is that it? All right. So let's make it, if I make it small, then that's it. All right. The flat fee is like the constant. That is like the x-intercept. So whenever you have a flat fee and you've got this x and y-axis, the D is the x-axis, the cost is the y-axis. And the $8 will be 10, 20, 30. The $8 on the graph is where it crosses the y-axis. So I'm going to put $8, a dot at 8, right just here underneath the 10. So that's where the 8 goes. And this 120 per kilometre, that's kind of like the gradient of the graph, because for each kilometre the cost goes up by $1.20. So that turns out to be the gradient. So for every distance, every 1 kilometre, it's going to go up every 1 kilometre. Let's go 10 kilometres. After 10 kilometres, it's going to go up $12. So for each kilometre, it goes up by $1.20. So for each, that makes sense, doesn't it? 10 kilometres is going to go up by $12. Yeah. So what's going to happen is after 10, it goes up $12. That'll go up to 20. Oh, that's the rubber. Goes up to 20, so it starts at 8, goes to 20, and if you get a straight line, it's going to look like that. However, the formula is the cost is simply 8 plus $1.20 for every D. So that is like how you take your flat formula, it's your constant. So that becomes your constant here, your flat fee. And $1.20 becomes like the multiplier of D. It's like the gradient value, or the multiplier for D. For times D is $1.20 times D. That's part A. Part B, which is, I'll just put above because I've already done it. The graph starts at 8 on the y-axis and it's got a gradient of 1.2. So if it goes for every 20 kilometres, it would go up $24. So after 20 kilometres, it should be up 24 above 8. So it should be up to 32. All right, so that's like 20, 32. That point there is 10, 20. So you've got a couple of points there. Part C, all right, find the cost for $14. Well, again, it's the rubber. I'll do black now. The cost equals 8 plus $1.20 times 14 kilometres. So 14 times 0.2, that's 280. Is that right? Plus 14 ones, so 1680. And plus the 8 is $24.80. You could have done that on the graph, but it's only approximate. So you look at 14, it's hard to see the graph to see exactly where that is, but it's at $24.80. So the formula will give you exactly. The graph can only give you approximately unless you've got a really accurate graph. And find the distance to keep the cost under 30. So let's find if $30 was the cost, we want to times it by something. So what I'm going to do here is I'll just take the 8 across to be 22. Therefore, if you take 22 and divide it by 1.2, you'll get your value. I'll do that on the calculator. 22 divided by 1.2, we get 18.3333. So we got to keep it under 18 1/3 kilometre. If you travel more than 18 1/3 kilometres, you're going to pay more than $30. So you could see at 20 kilometres, you're going to pay $32, and it turns out to be 18 1/3 kilometres, to be precisely $30. Okay, cheers.